Hello, Chem 2 students. It's Mr. Keister again with you today. This is the video for Friday, September 4th, which is our scheduled 12th day of school for the fall semester. This is also our second scheduled e-learning day school-wide. Always keep in mind, though, the dates could change for a variety of reasons, but the order of the lessons will remain the same regardless of that. So let's look at today's do nows, our agenda for today. Today we're going to review proportional reasoning, which you guys should have all done in Chem 1, which is another method of converting. Yesterday we did dimensional analysis, which, as I said yesterday, is going to be our primary means of conversion, since it is so useful in so many different areas of chemistry. Your homework for today was to complete that dimensional analysis assignment, and I am collecting that. So since we are on e-learning today, that means that you need to submit your assignment to me via Canvas. All right, you are not to email it to me like maybe you have in the past. We are going to do our first assignment submission in mass via Canvas. All right, so you need to go to my home page. I mentioned this on our first e-learning day, actually. You need to go to my home page and find the link that says how to submit your work electronically. Click on that. It will take you to a document that explains to you how to submit your assignment to me via Canvas, all right? Not via an email. Make sure you understand that, all right? This is our first test, so to speak, on being able to do that, sending your work to me as a class via Canvas. So make sure you do that. Of course, you can check your answers before submitting. Those answers are posted on my answer keys link on my homepage. All right. One thing I would remind you, though, that you show and label all your conversion factors as the instructions said to. Canceled them out, all right, so that I could see how you got from your beginning unit to your final answer, okay? So make sure that you did that, and make sure also you rounded your answers correctly. Remember, in conversions, we round our answer based on the number of sig figs in our original measurement, all right? Not on the sig figs found in all the conversion factors, all right? You round according to the sig figs in your original measurement. So today, during our lesson today, we will review how to do conversions using proportional reasoning. There will be an assignment over this that is due on Tuesday, since Monday is Labor Day and we are not in school that day. So let me go to the notes and we'll get going. So using proportional reasoning as a problem-solving technique. So proportional reasoning uses a for every statement, all right, to set up relationships as a ratio or proportion and solve by simply cross-multiplying and dividing, all right? So I'm going to show you here that there are multiple ways to solve these problems, with proportional reasoning being one of them, all right? And so we're going to run through all of those and then focus then on the one that's proportional reasoning, since that's our lesson for the day. So the first example, we have a density problem here. We're going to convert 500.0 centimeters of copper, so that's our volume, to mass, all right? The density of copper is 8.96 grams per centimeter cubed. So there's the density. So one way we could solve this problem is by using the density equation. We talked about this yesterday. So we could use D equals M over B. So again, now I'm going to follow the rules here that shows everything you're supposed to do. So we've labeled the data and identified the question. Here's our equation. We'll now plug in the numbers. So we have 8.96 as our density equals M over 500.0. All right. So we're going to solve for M. Okay. So basically, if I just put that over 1, we can then cross multiply like so. So we have m then equals 8.96 times 500.0. And based on the sig figs in our problem here, we have 4 here and 3 here. So then that would be 3 sig figs. Rounding this in, let's see if I need 8.96 times 500. Actually, the actual answer comes out to 3 sig figs, which is kind of handy. So m equals 4,480 grams. Okay. Secondly, we could solve this the way we did yesterday by dimensional analysis. So we want to find mass, so we're going to start with our volume, all right, which is 500.0 centimeters cubed over 1, and we'll use our density as a conversion factor. All right, so the centimeters cubed down here, the grams up here, there's 8.96 grams in 1 centimeter cubed. Centimeters cancel. Centimeters cubed cancel, I should say. And so we multiply that across. We're only dividing by 1. And again, now this one, we round according to our original measurement. Our original measurement has 4 sig figs. All right? So the actual answer was 4,480, which is only 3 sig figs. But how do we make it 4? Remember this? This is something you need to remember. That 0 currently is not significant, but what will make it significant is putting a decimal point right there. That makes that 0 significant. So now we have 4 sig figs. All right? This is a constant, the density. So that, again, in dimensional analysis, that is not used to determine sig figs. It's your original measurement. The original measurement is 500.0 centimeters cubed, which has 4 sig figs. So basically, same answer here, right? But different precision level. Different precision level. Okay. But you get the same answer, as you should. Okay. And now proportional reasoning. All right. So a proportional reasoning uses a for every statement to set up a relationship as a ratio or proportion. So our relationship here is the relationship between mass and volume, which is density, which is right here. So remember how to do this? For every 8.96 grams, there is 1 centimeter cubed. Or you could say it the other way around. For every 1 centimeter cubed, there are 8.96 grams. Either way, all right? And then we use that as a proportion, right? So we have 8.96 grams over 1 centimeter cubed. When we set up a proportion, remember, the units have to match up on both sides of the equal sign. We're not doing opposite and multiplying like we did here, because those units cancel. We don't want the units to cancel. These need to match up the same, so there's the same proportionally, all right? So we're looking for grams, which is x, and we have centimeters cubed, which is 500.0. Again, we cross multiply and divide. So basically we have x equals 8.96 times 500.0. So here we would use, again, our measurements here that were given. This is a constant, though, so we're going to go off our 4 sig figs again. And so that comes out to be 4,480 decimal point grams. 4 sig figs. Okay? So, as you can see, mathematically, the answer is the same, regardless of the method, as it should be. They're just done a little bit differently. All right? A little bit different. All right, let's go to the next one. So this last problem, we're going to do a unit conversion, okay? We're going to convert 2,500.0 kilojoules to calories, all right? and 1 calorie is equal to 4.184 joules. All right, so first, method 1, do we have a known equation for metric unit conversions? No, we don't. So there's really no known equation for that. We can solve it dimensionally, though. All right, so let's review that again. So we start with our given piece of information. Put it over 1. All right. So we need to get to calories. Now here we know that a calorie is 4.184 joules. We have kilojoules. So we need to do a metric conversion factor. We need to put a metric conversion factor in there so we can get to joules. So the kilojoules would be down here and joules up top. So here again, it's very handy to know how to use a conversion factor with the metric conversion line, the metric one. So kilojoules cancel. So we got kilojoules and joules. Kilo is bigger, so that gets the 1. They're 3 spots away, so there's 1,000 joules and a kilojoule. Now we can get from joules to calories using this English metric conversion over here. So the joules will go down here, calories up top, those cancel. In 1 calorie, there are 4.184 joules. So we're left with calories. We got 2,500.0 times 1,000 divided by 4.184. Oh, we get a very long answer. I'll write it down. 597,514.3403. So how many sig figs do we use in dimensional analysis? Well, we go by the original measurements number of sig figs, which is right there, which is 5. All right. So we got 1, 2, 3, 4, 5. But we need the ones place in that number too. So again, we're going to need a placeholder 0, just like we did the other day. So 597,510 calories. The 0 is a placeholder. So there's our 5 sig figs. All right. Okay. Now let's do it proportionally. All right. Well, as you can see here, in dimensional analysis, if we have 2 steps to do our conversion, then proportional reasoning is going to require 2 proportions. All right. So the first one, just like we did up here, we're going to convert kilojoules to joules. And then the second one, we're going to convert joules to calories. All right. So to get from kilojoules to joules, well, for every 1 kilojoule, we said there are 1,000 joules, or vice versa. Over here, for every, 4.184 joules, there is 1 calorie. Again, or you could say it the opposite way. So we got 2 separate proportions to do. This is what I was talking about. This is kind of why in this class and in your college classes, the dimensional analysis is the method of choice, because in a lot of chemistry problems, we are doing multiple step problems. In dimensional analysis, you can combine all those steps into one process. In proportional reasoning, you have to keep them separate. All right. So let's do that. So we're going to start with our first proportion. So based on this, 1 kilojoule is 1,000 joules. We set up the other side the same, and we are given 2,500.0 kilojoules and X joules. All right. So X then, when we cross multiply, would be 2,500.0 times 1,000, which would be 2,500,000 joules. Okay. I'm not doing any rounding because this is an intermediate step. We have another step to go before we get our final answer. So no rounding yet. All right. now we're going to convert joules to calories. So here's our for every. So there's our first proportion, our setup there. So we have 4.184 joules over 1 calorie. Set the other side up the same. We have our number of joules here, 2,500,000 and X calories. Okay? So I cross multiply. So I have 2,500,000 equals 4.184 times X. So we're going to divide out 4.184. And now we'll round again to our original measurement, sig figs, which is 5. And of course, mathematically, we're doing the same thing here that we did up here. I mean, here we took 1,000 times 2,500, and now we're dividing it by 4.184, which is exactly what we did up here in dimensional analysis. So I'm not going to do the math again. To 5 sig figs, I know it's 597,510 calories. 5 sig. Okay? So there you're solving the problems proportionally. All right? Proportionally. So that takes care of today's lesson. So you have an assignment that is due on Tuesday when we return from Labor Day. And until that time, this is Mr. Keister signing off. Take care, everyone. Stay safe and enjoy your long weekend. We all need it. All right? Have a good one, guys. We'll see you. Bye.